This is CPM Calculus, Chapter 4, Number 12. So Kai thinks that when the flags at right, here are the flags, are rotated around the poles, here are the poles they're getting rotated around, the volume of A, so the volume of this flag rotated around, plus the volume of C, just this section of the flag, equals the volume of B plus C, equals the volume of this entire flag rotated around the pole. Is Kai correct? Explain. Well, what we have to notice here is that region A rotated, right, is going to be this flag rotated around the pole is going to give us a cone here, right? A cone with it's basically going all the way around and has this height, right? A cone here, and we know the volume of a cone is equal to 1/3 pi r squared times h. R is the radius of the circle on the base, so that's 4, 1/3 pi 4 squared times h. H is the height times 3, and that's equal to the 1/3 and the 3 cancel out. That's 16 pi units cubed, because volume is units cubed. Okay, this region we know, so it's a little complicated. Let's go ahead and look. This was region A, right? Region C we could see is just a rectangle rotated around, and a rectangle rotated around the pole is going to be a cylinder. So the volume of this cylinder, right, is going to look like this. Right, just a cylinder, and that the volume of a cylinder is equal to pi r squared times h. It's just the area of the top is the circle, pi r squared times h is the height. So we can see that this has a radius of 2 on the top and bottom, so it's pi 2 squared, and a height of 3 times 3. So 2 squared is 4 times 3 is 12 pi units cubed, right? That's the volume of part C. Now finding the volume of part B is a little difficult. It's going to take a couple of steps because this one, part B, is not connected to the pole, so it's going to have, basically it's going to be this big cone with a center slice chopped out. Another way you can find this region is if we look for the region of B plus C. This region is basically going to be, if we extend this, it's going to be this triangle rotated about, so it's going to be a cone, right, minus the small cone of just the red area. So this area, we know that this has a length of 2, right? So if we were to go ahead and bring this triangle down here, like cut this off and copy it here, this would have side 2, so that would be half of this, and half of the base length is 1.5. Okay, so if we looked at the whole cone rotated around, the volume of the cone, the entire cone, is equal to 1/3 pi r squared h, and that's 1/2 times pi. The radius is now this whole base, so it's 4 plus 2 is 6 squared. H is this whole height, so it's 3 plus 1.5, 4.5, minus just this cone right here, minus pi, 1/2 pi r squared h, so minus 1/2 pi. This time the radius is this one, which is just 2. 2 squared times h is just this length, 1.5. Okay, so 6 squared is 36 divided by 2 times 4.5. Let's just use a calculator. So 0.5 times 36 times 4.5, and that gives us, did I do this? 0.5 times 36 times 4.5, yeah, is 81. Oh, sorry, volume of cone, because this doesn't look right, is 1/3 pi r squared h. So these should all be 1/3, excuse me. 1/3, 1/3, 1/3. That was my bad. So instead of 0.5, we have 0.33333, or I could just write 1/3. Now it looks right. So that's 54 times pi units minus 1/3 times 2 squared is 4 times 1.5. I believe that should be 2. Yes. Minus 2 times pi. Right? We still have the pi in there too. So that's 52 pi units cubed. Right? So B plus C is 52 pi units cubed. The region C, right, is just 12 units cubed. So B is just equal to B plus C minus C, right? That's B. So that's equal to 52 pi minus C is 12 pi units cubed. So that's equal to 40 pi units cubed. Okay? Okay. So as we can see, what's the volume of A? Volume of A here is, we found it to be 16 pi units cubed. So 16 pi units cubed. Plus volume of C. Volume of C we found is 12 pi units cubed. You add those together, you get 28 pi units cubed. And the volume of B plus C, right, we found to be 52 units cubed. So these are not equal, right? One is 28 units cubed, the other is 52 units cubed. So chi is not correct. So what is chi thinking? Chi is thinking that you rotate this around, but is not it. The area of B and A are the same, right? Because this side is 3, this side is 4. So these have the same area, these triangles. But when you rotate this one around, you're getting a bigger volume because it's further away from the pole. B is further away from the pole. So B makes a larger volume than A because it's further away from the pole. Because even though they're the same area, like the triangles are the same, B is further away from the pole that is rotating around. Okay, so if you were to look at A's cone, I'm just looking at the other way, it would be a cone like this, right? It would be a cone. B, though, would be a cone, like, but it would have a chopped off area, so it would kind of look like this. Okay, and this all would be connected to, and here it would be kind of like a volcano, or basically, I don't really know how to describe this, but it would be a cone with the top chopped off, right? No top, and also a hole in the middle as a cylinder. But the volume of A is less than the volume of B, right? Region B. Okay? So that ends for us CPM Calculus Chapter 4, number 12.